Right, we're going to do the CP2 revision mat, and I'm going to go down this first column and maybe have a look at these if I've got time. I'm going to try and keep these videos short so that we don't get bored. So explain the difference between vector and scalar quantities, a definition of velocity, and then calculating the speed travelled. So what I'm going to do is I'm going to move that out of the way first off. I'm going to bring across my trusty piece of paper, and I'm going to start explaining the difference between scalar and velocity. If I was to imagine that every quantity could be symbolized as an image, so I'm going to draw here, I'm going to draw an image here, and this is going to be of temperature. Okay, now this particular image, temperature, just is what it is. All right, now if I wanted to draw something like another quantity, another idea, if I wanted to draw something like north doesn't make very much sense to draw as a circle, does it? Because north has got a direction. So what I'll do instead is I'll use an arrow to describe that. North as a direction. Now, I know we might say that temperature can go up and can go down, but that's not really true, is it? Because 5 degrees Celsius and 6 degrees Celsius, they're relative ideas. So it's not like 6 is any higher or lower. Some things do have direction that come with them though. So for example, a force. If instead of thinking about north, I think about newtons, all forces have a direction. If I draw the Earth, the force due to gravity always goes down towards the center of Earth. Every force has to have a direction. If I think about two different surfaces going over, rubbing over each other, so if I've got surface A and if I've got surface B, and I make surface B go this direction and I make surface A go that direction, then there's a force that's generated. There's going to be friction in between these two blocks, and that will be a directional thing. Mass, okay, if I have a 1 kilogram weight, that 1 kilogram mass, it is 1 kilogram, and nothing will change that. However, if I put a little astronaut in space, and if he was 100 kilograms down here on Earth, when I put him up into space, he will be what we call weightless, or have less weight. Because even though he would still have 100 kilograms of mass, he would have a very, very, very small amount of weight. Because weight is measured in newtons, weight is a force, weight changes depending on where you are. So what's that roundabout way of saying? The roundabout way of saying that is that there's two different types of quantities. We've got two different ways of describing different numbers. We have what's called a scalar, and we have what's called a vector. And they're slightly different things. So a scalar, what we say, it has only magnitude. Magnitude just means it has a number and a unit. So hashtag, that doesn't mean hashtag then a tweet like, that just means number, and then I'm going to add a unit to it. Vectors are slightly different because they have this, but they also have a direction. So we can give an example of a scalar measurement being mass, because it has no direction. We can give an example of a vector unit being force, because all forces have to have directions. And there are what we call counterparts as well. So I can think about some scalar measurements that will match up with vector measurements. So we think about the word speed. We talk about high speed chases and going whatever speed you like in your bike. Its counterpart is velocity. So velocity is a speed plus a direction. Units of speed, meters per second. The units of velocity, meters per second, and a direction. Up, down, left, right, north, whatever happens to be the case. We've already talked a little bit about mass. Mass has got no direction. Its units are kilograms. Weight, however, is the effect of gravity on mass, and it does have direction. It's a force. We can also talk about distance and displacement. Now some people get a little bit mixed up by this. They mean nearly the same thing. They're both measured in meters, but there's a slight difference in that displacement has got its direction, but they are still both measured in meters. So I'm going to explain displacement and distance now. This is point A and this is point B. And if I want to find the distance between point A and point B, it's very simple. If you go this way and then that way and then this way and then that way and then and you go around a tree and then you go back to point B here, this orange line is the distance. What I do is I add up all the straight lines, I measure the curves with a piece of string, I add them all up together, and that gives you my distance in meters. But you see how the distance has got lots of changing directions. And then I can draw straight line tangents, but we're not going to do that too much. I'm just going to go through this. The direction has changed so much that there isn't one particular direction that we're going in. Displacement is slightly different. Displacement starts at A and ends at B in a straight line. So I would say that the displacement of this is, I don't know, 25 centimeters right. The distance could be something huge, like 70 centimeters, but I can't give it a direction. There are lots of different examples of scalar and vector measurements, time and temperature and energy, lots of vector measurements, acceleration and momentum and any force. All of those things are available in your revision guide. Now it's asking me to calculate some speeds. Now I love maths in physics because it's so easy for us to get the marks that we need. Okay, the equation that we're going to need to find the speed traveled between 2 points is speed is equal to distance divided by time. A derivation of that then, d is equal to s divided by t, and t is equal to d divided by s. They are your rearranged equations. Now I recommend that you spend some time learning how to rearrange equations easily and quickly, because it's a useful skill. What I'm going to do now is I'm going to do question 1. Calculate the speed travelled between 0 and 6 seconds in figure 1. But for this I'm going to have to use my trusty zoom. I don't know how to use my trusty zoom. If you look down here in figure 1, it gives us some time between 0 and 6 seconds. So I've got to try and find the distance on this y-axis between 0 and 6 seconds. So simply I go across to 6 seconds, I go up to the intercept with my line, and then I go across to the y-axis and I see how far we've gone. Now it's a line in between 18 and 20, which tells me that it's 19 meters. So I can now collect my terms. I can say that the distance travelled was 19 meters. I can write down that the time taken was 6 seconds, and it's asking me to calculate the speed. For my mark, I'll do speed is equal to distance divided by time. I will say that distance is equal to 19 divided by 6. I will realize that I don't have my calculator handy. 19 divided by 6, and the answer will be 3.17. The units I'm going to use are meters per second because my handy zoom function, the y-axis is labelled as meters and as seconds. You do the exact same thing for all the other questions and you'll be absolutely fine. The method doesn't change, only the numbers. If we were to calculate the acceleration, however, that requires a different set of calculations. So the next one then, analyze figure 2 to calculate the acceleration between these 2 points. The equation for acceleration then, A is equal to delta V divided by T. What does delta V mean? Delta V means V minus U all over T. Don't get put off by these symbols. The second you start using them, you'll get familiar with them, okay? V is the end velocity, U is the start velocity, and T is the time taken. This will be measured in meters per second. This will be measured in seconds. So it's asking me to use this calculation to find the acceleration in this figure. So between 0 and 6 seconds in figure 2. 0 seconds is here, 6 seconds is there. The exact same thing that I did last time. I'm going to go up and I'm going to see what my final velocity is. I'm going to move over to the y-axis and I'm going to see that it's 34 meters per second. My start velocity is obviously 0. the time taken will be 6 seconds. So now I can collect my terms. So they're asking me to find the acceleration, so I don't know it. The end velocity was 36 meters per second. The start velocity, 0 meters per second. And the time taken, 6 seconds. Acceleration is the change in velocity divided by time taken. Acceleration will be 36 minus 0 over 6. Acceleration, 36 divided by 6, 6 meters per second squared. Next section then, calculate the distance travelled between 0 seconds and 6 seconds in figure 2. Well, slightly different here. We use the area underneath the line to find this. And the reason being, I'll get a new piece of paper for this. Exciting. The reason being that the distance travelled is equal to the speed multiplied by the time. Alright. How do I find the speed? How do I find the time? Oh, hang on. What's going on with something? How do I find the speed? How do I find the time? Well, this is what we call a velocity time graph. So the velocity is the speed and the time is the distance. How do we find the distance? We multiply that by that. But because we're accelerating, we've got a line here, I can only use half of that measurement because it's a triangle. Which is why we get to use the area underneath the line to find the distance that we've travelled when we've got a velocity time graph. That's my triangle, and I will find the area under here by multiplying the velocity by the time and then halving it. So the equation for it then, if we've got a triangle in one of our graphs, is 1/2 the base times the height, which can be 1/2 the time by the velocity. So if I want to find the distance travelled for this particular car or whatever, I will find the speed, 36 meters per second. I'll find the time, 6 seconds, and I'll be able to work out the distance travelled. Again, I'm going to collect my terms. Distance, I don't know. Speed, 36 meters per second. Time, excuse me, 6 seconds. Distance equals 36 times 6. Distance equals, again, get my trusty calculator. 216 meters. Alright, that's enough for now. Have a crack at them, see if you can do some questions, and if you've got anything that you're puzzled about, let me know and I'll talk you through it. Don't forget to log into your teams, don't forget to check WHA Science, and stay safe.